2006, Form B, Problem 1 says, let f be the function defined by f of x equals x cubed over 4 minus x squared over 3 minus x over 2 plus 3 times cosine of x. Let R be the shaded region in the second quadrant bounded by the graph of f, and let S be the shaded region bounded by the graph of f, and line L, the line tangent to the graph of f, at x equals 0, as shown above. For part A, you're asked to find the area of R. To get started, I would recommend that you go ahead and have your calculator graph f of x. No need to be anybody's hero and try to do something like that by hand, especially when you're in a time constraint, okay? In addition to typing that in, I wanna make sure that you always check to make sure you're in radians mode, and then choose a window that's appropriate. Now for this problem, I just copied off of the picture. It made sense to go from like either -3 or -2 to 4 for x, and then it made sense to go from -3 to maybe 3 or 4 for y. So that's where I got my ideas for my window, and then I went ahead and just graphed it. And as long as my picture on my calculator pretty much looks like what I see given, then I'm pretty pleased. So there you go, okay? Now, let's find the area of R. I hope it makes sense that really the graph here is gonna help us with figuring out the correct bounds because they didn't tell us what x coordinate that is right there. So to figure it out, I'm gonna use the calculate feature, and then I'm gonna use from there, I'm gonna choose 0, which would help us find the coordinates of that x-intercept over here. That'll help me set the lower bound for my integral. So, okay, so here I've got the number right there. Okay, I'm gonna use that move where I let a variable, I usually start with a and then go from there. 0.373122, mostly because I might trust myself to copy a decimal down correctly once, but I really don't trust myself to write a decimal down more than that. All right, so now I'm gonna go ahead and store that number. So I'm gonna type it in and store it as the letter A, whoops. Store it as the letter A. All right, and then so on paper and in my calculator, everybody knows A means that decimal. There we go. Okay, so to set up an integral for the area of region R, we could basically say, I guess I'll label it. So it equal the integral from that A value to 0. And then for this one, upper minus lower would just be f of x minus 0, or just f of x. There we go. All right, now it's just a matter of typing things in on your calculator to make it do the integral for you. All right. There we go. And then I ended up with approximately 2.903 and its area, so I'll go ahead and just say units squared. There we go. Hope that makes sense. Okay, part B. Find the volume of the solid generated when R is rotated around the horizontal line, y equals -2. So they're still just talking about region R. So I'm just going to draw a little concept picture here. All right. So here's y equaling -2. Now let's go ahead and reflect that shape over and then kind of try to turn it into something that's somewhat 3D looking. I feel like I drew this way too small. Anyway. Yeah, sorry, super small. Okay. So here is my typical cross section. I'm going to get away with a dx integral because as I scan the x-axis, I accumulate more and more washers. So here we go. Volume would be pi times the integral. We want to start accumulating washers at A and stop accumulating washers at 0. Now let's figure out what your outer radius would be. Your outer radius would be f of x is this distance, but then plus 2 more units. So outer radius squared minus, and then the inner radius would be 2 no matter where you're at. So constant value of 2, and then as mentioned before, it is a dx integral. There you go. Okay, typing it in. Let's see. Okay, looks like I got approximately 18.895 pi. Just multiply that by pi, and we end up with 59.361 cubic units. There we go. Either of those answers would work great. Okay. Part C. Write, but do not evaluate an integral expression that can be used to find the area of S. Okay. Now, finding the area of S would be fairly straightforward because it's just upper minus lower. The trick is we need to find the equation of line L. And what do we know about line L? Well, we know it's tangent to the graph of f where x equals 0. And my friends, you've known how to find the equation of the tangent line at a point to a graph for a long time. So let's just make sure you know it's time to apply that skill at this time. Okay? So goal number 1 is find the equation of line L. So figure out a point that line L hits. And you could tell by looking at the graph that's probably at 0, 3. But even easier, this is it looks like a crazy function rule, but imagine plugging 0 in. All these first 3 terms would be 0, and then cosine of 0 is 1 multiplied by 3. So that point that line L definitely hits is the point 0, 3. And you could have, yeah, I mean, you think that's pretty much the point that you'd need there. So the point of tangency is 0, 3. Now let's find the slope of line L by using the fact that it's tangent to the curve at 0. So the slope of line L would simply be f prime of 0. Okay, and there are 2 ways that you could do this. You could do the derivative of this by hand. No big deal, I trust you could do it. And then you could just plug 0 into the answer and see what you get. You would end up getting -1/2, okay? So the answer should be -1/2, okay? You could have done it by hand. I also though want to take this as an opportunity to show you that your calculator can do numerical integrals like we've been doing, and it also can do numerical derivatives. So you may have kind of noticed this when we were going for option 9. Option 8 right above it is numerical derivative. So to do this, first thing I would enter in is what function rule I want it to take the derivative of. I want it to take the derivative of f of x, or what I programmed in is y1. Next, I'd say what I want it to take the derivative with respect to. I want it to take the derivative with respect to x. And last, you say what number you want to plug into it. So I want it to plug 0 in, and then I'll just push enter. There will be sometimes a strange little round off error, but however, if we round this to the thousands place, 10,000s, whatever, you're going to basically end up with that -1/2 that we have here. Okay, so what is then the equation of line L? Well, it would end up being y equals -1/2 x plus 3. There we go. All right, so now I know what to put in for upper. So now I can set up my integral. Almost, actually. So now that I know the equation of the line right there, I'm going to need to know what my upper bound is going to be for this integral. So to figure that out, let's make our calculator figure it out for us. So negative 0.5 x plus 3. Let's go ahead and graph that. There we go, and it looks great. Anyway, and then we can use the intersect feature to figure out the right number to use there. All right, you're going to see some signs of technical difficulty here anyway. So I found this point of intersection at 1.3 something something. I'm not going to bother with storing it because I only need to write it once. So the area of region S would be the integral from 0 to this 1 point, oh no, it's not that number at all. That's the y value. Don't do that. 3.3898677. Good night. 3.3898677. Okay. Upper is the line graph, and then minus lower, which is f of x. There we go. They didn't ask us to evaluate it, so we just set it up and call it a day. Anyway, watch out for those problems with those directions. It's no fun trying to, like, grunge it out when you didn't really have to. Okay, so with that said, let's talk about scoring guidelines. So they said 1 point for the whole integral for part A, 1 point for the number here. For part B, 1 point for the bounds and the constant of integration. So remember, there's no half points, so all or nothing on that. 1 point for the integrand. And then 1 point for the correct answer. Could have been in terms of pi or where you multiplied pi in. And then for part C, it was 1 point for getting the equation of the tangent line, which you could show up here or inside your integral. 1 point for getting the integrand correct. And 1 point for having the correct bounds. There we go. Okay. Anyway, so please write your raw score out of 9. Celebrate every point, my friends, and then go ahead and show that after edits you did get 9 out of 9. Show some celebration of some kind. Anyway, there you go. Hopefully things are making a little more sense as we go, even the tough stuff. Anyway, and if not, don't worry, hang in there. It'll make sense soon. Take care, everybody.